यार सर्दियों के साथ बहुत सारी चीजें चली जाती हैं,
जैसे
जैसे हमारी टाइम पास वाली मूंगफली
और गर्मा गर्म अदरक वाली कड़क चाय।
और खाने के बाद ये गजक, सब चला जाएगा यार सर्दियों के साथ।
ऐसा नहीं है भाई, सर्दियां जा रही हैं लेकिन सुपर कोचिंग पर डिस्काउंट भी तो आ रहा है। सुपर कोचिंग लेकर आ रहा है विंटर फेयरवेल सेल, जहां पर सभी कोर्सेज पर मिल रहा है 90% तक का डिस्काउंट।
Hi, good evening everyone. This is Shefali Singla, and in this session we will be discussing few more set of questions from Unit 2, that is specifically from digital logics. तो आज वाला session last session है on the practice of digital logics. After this we will be discussing the questions from computer organization and architecture. So in today's session we will be discussing like 7 to 8 questions like we do in every session. So हर question के लिए बेटा आपके पास 30 seconds to 1 minute का time होगा, and just give it a try. आप try कीजिए. अभी तक वैसे almost हम सारे concepts कर चुके हैं, so you must be comfortable with all the concepts of the digital logic. Now you have good idea that what sort of questions have been asked in the UGC NET exam from Unit 2. Very good evening Nitika, good evening Sarika. So चलिए start करते हैं from the first question. So okay. So first of all, you are given with some function with 4 variables a, b, c, d, और आपको k map use करके इसको minimize करना है. That means simply you have to construct 4 variable k map, mark the entries, and you will get the cells with the entries 1. यहाँ पे जो आपको options में expression दिया हुआ है, this is nothing but this is SOP expression. That means we need to focus on covering ones. So let's construct the 4 variable k map. मैं थोड़ा सा स्लो कर रही हूँ ताकि फटाफट आप लोग अपना आंसर फाइंड कर ले. k map के साथ अब सब लोग कंफर्टेबल हैं. A, B, C, D, and we know that k map works on the gray coding scheme. This is A complement, D complement, C complement, D, C, D, and C, D complement. So we have 4 rows and 4 columns. We have 4 rows and 4 columns. This is A complement, B complement, A complement B, AB complement, and AB. So gray coding scheme use हो रही है. Gray coding means unidistant code. So this is 0 0, this is 0 1, 1 1 1 0. So it is unidistant 0 0 0 1 1 1 1 0. उसके अकॉर्डिंग आप सेल्स को मार्क कर लेंगे. So this cell is 0, this cell is 1, then this is the binary for 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now mark the entries here. आपको function में given है. So this is given as, okay, let me take this one. So entries are marked on 0, 2. This is 1, 2, then is 5, 7, 8, 10, then is 13 and 15. We have marked all the entries. Don't care, कुछ भी नहीं बताया हुआ है. Here the focus is to find the group of the maximum size, क्योंकि जितना बड़ा size होगा group का उतने literals कम use होंगे. So in this case octet is not possible. 16 ones आ नहीं रहे. Then we'll go for octet. Octet is not possible. So we'll check for the quad. Are we able to get the quad here? Yes, quad is possible. So this is first quad. ये पहला quad बन गया. And second quad is on the corners. Fold all the 4 corners, you'll get the second quad. अब सिर्फ और सिर्फ आपको naming convention use करना है, and you need to name these 2 quads. So जो corners वाला है इसमें first and the last row use हो रही है. इसमें B complement is common. First and last column use हो रहा है. C complement, D complement, C, D complement. So D complement is common. So this is B complement, D complement. For the quad which we are getting in the middle, for this middle two rows and middle two columns. So B is constant and D is constant. So this comes out to be BD. So correct answer for this question is BD plus एक quad बना with the name BD, दूसरा quad बना with the name B complement D complement. So this is the minimized expression. That is option 1. Okay, very simple. I hope you all are comfortable. In fact, we talked about the variable entered KMAP. So usually जो minimization पे question आता है, that is from 3 variable or 4 variable KMAP. So just you need to focus on finding the correct groups and definitely you'll get the minimized expression. Next question, the Boolean expression is given to you is equivalent to. So you are given with the Boolean expression and you have to return the minimized expression. Try to apply the Boolean laws. It is A complement B plus AB complement plus AB. So anything that you can take common. If I talk about the last two terms, so here I'm getting A common. So I'll get the expression as A complement B plus, if I'll take A common, it will be B complement plus B. And we know that this term is always equal to 1. We have proved this. You can take any value of x की value 0 या 1 हो सकती है because each variable will be represented with any of the bits 0 or 1. So this expression comes out to be 1 and we know that for multiplication identity is 1. यानी कि अगर आप 1 से मल्टीप्लाई करवाते हो किसी भी नंबर को तो रिजल्ट वॉन्ट चेंज. Similarly, the identity for addition is 0. किसी भी नंबर में आप अगर 0 ऐड करते हो result remains the same. So a dot 1, this is going to be a only. So we can write here this expression is equal to a complement b plus a. Further, we are not getting anything. So let's minimize it further by applying the distributive law. So it comes out to be, we know that x plus yz is nothing but x plus y into x plus z. So I'm going to use this distributive law here. So we'll get a complement plus a, b plus a. A complement plus a, again first rule is used. So this is 1 multiply with a plus b, that is nothing but a plus b. Identity law. So minimized expression is option 1, that is a plus b. No Sarika, it's not option 2, this is option 1, a plus b. It's not a multiplied by b. Easy? If yes, then let's move on to the next question. Okay, now here you are given with the series of XOR gate. आपको थोड़े से concepts use करने XOR gate के. You know that how XOR gate works. So let this symbol denotes the XOR operation. Let 1 and 0 denote the binary constants and F is the Boolean expression over the two variables. आपको कोई Boolean expression दिया हुआ है. This is the Boolean expression given to you. Let me write here. PQ is equal to, this is 1 XOR P. Can somebody tell me that what is the functionality or what is the property of the XOR gate? XOR gate क्या करता है? P XOR Q bracket closed plus P XOR Q XOR Q XOR 0. Let's revise the properties of the XOR gate. After that, you just need to apply that and easily you'll be able to get the answer. So first of all, we know that XOR gate में output 1 कब आती है? When can we say that the output will be 1 in XOR gate? Come on. When we have different inputs. So XOR gate में output 1 आती है when we are having different inputs. That means if you are taking A XOR A complement, क्योंकि अगर A की वैल्यू 0 है तो डेफिनेटली A complement की वैल्यू 1 होगी. So this is going to return 1. If I'm taking the same input के साथ XOR ले रहे हैं, then output will be 0. अब मैंने आपको एक रूल बताया था कि you can change these values, you'll get the other set of rules. So if I'm writing a XOR 1, that will be equal to a complement. Make sense? Okay. Now let us use this, and if I'll apply this rule here, a XOR 0, आप यहां से फाइंड कर सकते हो. यू कैन कंसिडर सम वैल्यू ऑफ ए. अगर a की वैल्यू 1 है, दिस कम्स आउट टू बी 1 XOR. इफ आई एम कंसिडरिंग दिस एक्सप्रेशन a XOR 0, मुझे वैल्यू फाइंड करनी है. आप कैसे फाइंड कर सकते हो? यू कैन पुट द वैल्यू ऑफ a and see what result you will be getting. If a is equal to 0, then it will be 0 XOR 0. Both the inputs are same, so output will be 0. If a is equal to 1, then it will be 1 XOR 0. Both the inputs are different, so output is 1. That means output a की value पे depend कर रही है. अगर a की value 0 है, then the output is 0. If the value of a is 1, then the output is 1. So we can say that a XOR 0 is nothing but it is equal to a. आप यहाँ से भी prove कर सकते थे, or you can just take the values and substitute. Now let's simplify this expression. We know that 1 XOR a, that is a complement. So can I write this as p complement? XOR as it is आया. Now we are getting p XOR q. p XOR q, bracket closed, plus p XOR q. अभी हम इसको expand नहीं कर सकते. p XOR q, and this is nothing but q XOR 0. a XOR 0 is a, so q XOR 0 is a. So XOR, this is q, because this term is coming out to be q. Bracket, second bracket is closed. Now again you can simplify it further. p XOR p, p complement XOR p. अगर complement के साथ XOR ले रहे हो, that is 1 XOR q, plus p XOR q XOR q XOR q. If both the inputs are same, output is 0, so this comes out to be p XOR 0. Any input with the XOR 1, किसी भी input का जब आप 1 के साथ XOR लेते हो, this is returning the complement, plus p XOR 0, this is returning p. So it comes out to be q complement. This was what we have done. So here we had the multiplication. Okay. So now we need to apply. We are getting here, this is the actually XOR. Now we are getting the XOR. We know that a XOR b is nothing but this is a complement b plus ab complement. So substitute the values here. We'll be getting a complement b plus a b complement. So this comes out to be qp plus q complement p complement. Now this is nothing but this is the XNOR gate. p XNOR q. XNOR के साथ आपको option दी नहीं हुई है. So we know that if the number of inputs are even, then it's the complement of the XOR. p XOR q complement. So this is the option here, that is p XOR q whole complement. So correct option for this question is it's option 4. Is this clear? So if you are comfortable with these rules, you just had to apply these rules. In rules को apply करके आपके पास simplified expression आ जाता है, and we had to return the simplified expression. Next question. Which of the following circuit is used to store 1 bit of data? So this means that this is related to the storage component. Storage component means जहाँ पे memory है. Memory means we will be talking about some Sequential circuit. So what should be the answer? Which of the following circuit is used to store one bit of data? Store means storage. Storage is the functionality of memory. And we know that memory component is present only in the sequential circuits. And in the sequential circuits we have flip-flop that is used to store one bit. We have registers which is used to store group of bits. Encoder or decoders आपके पास combinational circuits है. These two are the combinational circuits. That means clearly option 1 or 2 cannot be the answer. These are the combinational circuits. So 1 and 2 cannot be the answer. Flip-flop is used to store one bit data, whereas registers are used to store group of bits. What if I want to store 4 bits? अगर मुझे 4 bits store करवानी है, how many flip-flops should be grouped? How many flip-flops should be connected in order to store 4 bits of data? Clearly, एक flip-flop एक bit को store करवा रहे. If I want to handle 4 bits of data, then I need to use 4 flip-flops. अगर 10 bits का data handle करना है, then we need to use 10 flip-flops. So clearly, it depends on the number of inputs. Did I mark the answer? Okay, so store करवाना है storage and 1 bit of data. So that means it is not register. It is clearly the option 3, that is flip-flop. Next one. Again, this is related to flip-flop. In RS flip-flop, the output of the flip-flop at time t plus 1 is same as the output at time t. यानी कि आपके पास जो output है that remains the same. So output same कौन से case में रहती है? In December net, this question was asked. So I already told you that I'm taking the questions from the previous year papers only. So definitely कहीं ना कहीं पे आपने ये questions देखे हुए होंगे. In RS flip-flop or SR flip-flop, we know that in SR flip-flop, so clearly with 2 inputs, 4 combinations are possible: 0, 0, 0, 1, 1, 0, and 1, 1. So we know that in SR flip-flop for 0, 0, there will be no change in the output. No change. 0, 1 means output will be fixed. 0, 1, and this is invalid combination. This is not used. Because इस case में क्या हो रहा था? For both the outputs of the flip-flop, किसी भी flip-flop की 2 outputs होती है, Q and Q complement. So in both the cases, we were getting the same output. So which is impossible जबकि outputs complement होके आती है. So that was the problem. So कौन से case में change नहीं होती previous state से output? That is when S and R both are equal to 0, or this is nothing but this is the truth table. बाकी आपको पता है truth table से हम characteristic table कैसे बनाते हैं? So in the characteristic table, we need to consider the previous output as well and return the value. So I'm constructing the characteristic table, although हमारे पास answer आ चुका है, but it's a quick recap. So T and T plus 1, that is the next output. Next output. What will be the next output? So with 3 inputs, we know that 8 combinations are possible. So let's take all the 8 combinations. So we are getting here 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1. Now, if S and R both are equal to 0, that means there will not be any change in the previous output. यानी कि अगर previous output 0 है, then the output will be 0. If the previous output is 1, then the output will be 1. So here it is not changing the output that we have obtained in the previous step. If S and R is 0 and 1, then it is going to return 0. Doesn't matter what is the previous output. So this is returning output 0. If it is 1, 0, then it is returning the output as 1. And if it is 1 and 1, doesn't matter what was the previous output, this is the invalid case. Although आपको ये कैरेक्टरिस्टिक टेबल नहीं बनाना था, बट दिस इज यूजफुल व्हेन यू आर डेराइविंग द कैरेक्टरिस्टिक इक्वेशन. आपसे पूछा जा सकता है क्वेश्चन, व्हाट इज द कैरेक्टरिस्टिक इक्वेशन ऑफ द एसआर फ्लिप फ्लॉप. So we had already derived that, you know, that from characteristic table. So like this is the characteristic table. For t plus 1, you will be coming up with the minimized expression, and that will be behaving as the characteristic equation. So this table with the 8 entries is nothing but this is the characteristic table of SR flip-flop. Characteristic table. Next question. Here you are given with some laws. आपको कुछ identities given है and you are given with the name of the laws. So you have to map which one is mapping with which name of the law. जो मैच द फॉलोइंग वाले होते हैं ऑलवेज स्टार्ट फ्रॉम द ऑप्शंस जो जिनको लेकर आप श्योर हो, क्योंकि उसके बेसिस पे कई बार ऑप्शंस खत्म हो जाती हैं. सो स्टार्ट फ्रॉम वेयर यू आर कंफर्टेबल. Come on, right now only I have discussed two names. Any idea, any guesses? Right now we have talked about the identity. What is the identity for plus? Identity क्या है इसके लिए? If I'm adding 0 to any number, I'll be getting the number itself. So this means that 0 is the identity. For plus. Similarly, किसी भी number को जो आप multiply करवाते हो 1 से, तो कोई change नहीं आता है. It remains the same. So 1 is the identity for multiplication. So x plus 0 is returning x. This is nothing but this is the identity law. So B के लिए option 1 है. This means that on the basis of this, we have eliminated the option 2 and 4. ये सबसे बेस्ट अप्रोच रहती है कि ऑप्शंस ही एलिमिनेट कर दो. देन वी नो दैट x plus xy is equal to x. So this is going to absorb some expression and it is returning just x. So what is this? This is nothing but this is the absorption law. That means D is 2. D is 2. So on the basis of this, even this option is also eliminated. X plus x is equal to x. This is nothing but this is the idempotent law. And then we are left with x plus 1. This is the domination law. यहाँ पे कौन dominate कर रहा है? 1 dominate कर रहा है. कैसे dominate कर रहा है? कि अगर आप 1 के साथ किसी भी input का और लेते हो, output 1 ही रहेगी. Doesn't matter what is happening. So that means it is showing the dominating behavior. So it is the domination law. So for C it is 4. So correct answer for this question is it's option 3. कुछ भी नहीं करना था. अगर आपको laws पता है, identities पता है, you just need to map it. Next one. Again you are given with two lists. कुछ functions given है, list 1, and you have to identify this is mapped with which one. Just give it a try. Like in the first attempt, we can easily understand one thing, the universal gate. इनमें से कौन सा gate है universal gate? So what are the universal gates? Universal gate का मतलब होता है using that gate you can implement any gate. You can implement any gate. So what are the universal gates available? कौन से universal gates available है? I cannot see any response. So we have two universal gates, that is NAND and NOR. Check for the options. NAND and NOR are the universal gates. We are getting the NAND gate. So this means that B के corresponding क्या आएगा? 1. Corresponding to B, we are getting 1. सिर्फ एक ही जगह पे आ रहा है, खत्म होगी बाकी options. Even if you are not comfortable with other things, then also you could have marked the answer correct. Okay. Moreover, for odd function means we are counting odd number of inputs. So which gate is used? If it is 1 XOR 0, then only you'll be getting 1. If I'll be getting 1 XOR 1, then I'll be getting the output as 0. If I'll be getting 1 XOR 1 XOR 1, then I'll be getting the output as 1. So basically, XOR gate is counting the odd number of ones. So odd function is implemented by XOR gate. That is, for A, it is coming out to be 2. 2. For this, it is coming out to be 1. 2, 4, 2, 1. जब हमने practice questions start किए थे from digital, I took this example 2, 4, 2, 1 and I explained that what is a self-complementing code. So 2, 4, 2, 1 is a self-complementing code. So this is 4. Then is the buffer. Buffer is used for amplification. So this is 3. Even if you are not comfortable with this amplification thing, then also हमारे पास ऑलरेडी आंसर बाकी के ऑप्शंस पे आ जाएगा. इसलिए जरूरी नहीं कि आपको सीक्वेंस में काम करना होता है. जब भी इस टाइप का क्वेश्चन हो, जिन भी टर्म्स के साथ आप कंफर्टेबल हो, फेमिलियर हो, स्टार्ट विद दोस टर्म्स. So answer for this question is option 2. So with this we have covered the questions from Unit 2, digital and computer organization and architecture. So from tomorrow's session, I'll be discussing the concepts through questions from Unit 2. Unit 2 का topic हम लेंगे core. Anyone having any doubt in any sort of question or any concept of digital? So I guess approximately we had 7 to 8 sessions in which we have just discussed the questions of digital. तो almost सारी type के questions आए हैं हमारे पास. Counter से question आया, register से आया है. We have got the questions from the combinational circuits. Then we discuss the questions from logic gates. और सबसे ज़्यादा question किससे आ रहे? Number system and minimization. So these two are very very important topics. So revise all these topics in detail. Hope these sessions are useful for you guys. If you guys have any doubt or query, you can ask. And those who are new on this platform, on this channel, so we are having the super coaching batch, जिसमें हम लोग पूरा syllabus paper 1 और paper 2 का detail में live sessions में cover कर रहे हैं. Every day we are having the sessions and we are also solving the questions. So if you want to take the benefit of the super coaching, then you can go through the link which is given in the description box. And the best thing is currently the winter off sale is going on. So winter is going. So winter off sale is going on, जिसमें आपको super coaching में up to 90% का off मिलता है. For that you have to use the code Shefali S. So don't forget to use the code, otherwise you won't be getting the discount. So this is the code if you want to join the super coaching batch. Let me discuss the schedule. Agenda is कि हमारे पास सारे के सारे topics live session में cover हो. Moreover, we will be finishing off the whole syllabus by the end of April, so that आपके पास जो test series है उसके questions को solve करने का, doubts पूछने का enough time मिले. Goal जो आप लोगों का goal है वही हमारा goal है. What is your goal? मैंने बोला नहीं है what is the goal, so what is your goal? For your reference, I'm writing the timings for the sessions of paper 1 and paper 2. Guys, what is your goal? This is at 12:30 noon every day except Sunday. And for paper 2, we are having one session in the morning and other one in the evening. For morning, timing is 7:30 a.m. to 9:30 a.m. 7:30 to 7:30 is not possible, right? Okay, 7:30 a.m. to 9:30 a.m. and in the evening it's 8 p.m. to 10 p.m. No weekends off for paper 2. no weekends off. वीकेंड से मेरा मतलब है सैटरडे एंड संडे, कोई भी सैटरडे एंड संडे ऑफ नहीं है, ताकि आप लाइव सेशंस को इजीली ज्वाइन कर पाओ. नो वीकेंड्स ऑफ. सो in order to take off, we have kept some days in the weekdays. So morning session is off on Thursdays. Thursday morning is off. And for evenings, this is Monday and Tuesday off. So as per the schedule, so tomorrow it should be off, but as I have already announced, this Thursday we are not taking off क्योंकि unit 2 almost खत्म है, सिर्फ एक topic बचा है, so I'll finish that topic here. So we are on the track. जो हमारा structure है हम उसी के according चल रहे हैं, और जो लोगों को structure नहीं पता है, please go through the link which is given in the description box. And apart from that, you can also join the Telegram group. So जो भी आपकी queries है, जो भी आपकी concerns है, you can post that and definitely it will be considered. So for the Telegram link, again refer to the description box. Okay. And apart from these sessions, I'm taking the YouTube sessions. YouTube में हम सिर्फ और सिर्फ concepts कर रहे हैं. Basic agenda for the YouTube session is the revision of the concepts which we have already covered, or learning the concepts through questions, ताकि concepts, अगर कहीं किसी भी concept में doubt है तो आपका concept clear हो जाए. Concepts through questions. So dedicatedly I'm not taking any particular session on a particular topic, but if you feel like कि इस particular topic में एक दो topics we can cover, so अगर आपको लगता है कि ये particular topic पे आपको revision चाहिए, then please let me know. Definitely I'll consider that. Okay. YouTube session timing is 6:30 p.m. since this is in the evening. So again, Monday and Tuesday is off. Monday and Tuesday is off, but no off on weekends. So this is the structure that we are following. Anyone having any doubt or any query? If no, this is all from my side. We'll end our discussion here. Again, I'm repeating this point. जो लोग super coaching join करना चाहते हैं, guys, currently the sale is going on. तो अगर आप join करना ही चाहते हो तो this is the best time to join it. So you can do that. Moreover, आपका syllabus भी नहीं छूटेगा. So from today we will be starting with the new unit, that is with the system software and the operating systems. All right. So this is all about this session. I'll see you tomorrow evening. Till then, take care. Bye bye. God bless you. Good night.